Hello everyone, welcome to my YouTube channel. My name is Shivam Kumar and I am again here with a new video. I do not upload videos on a regular basis, but if I tell you, I actually love to upload videos, to make videos, and whenever I get time, I always try to upload a video on my channel. And today I have also come up with one another video, and in today's video, I am going to solve Leetcode problem number 3651, and I hope that you will find the solution good and easy to understand. So actually this video is very lengthy, so without doing much delay, I will directly move on to the discussion page. Okay, so let's move on to the discussion page. This is Leetcode problem number 3651, minimum cost path with teleportations, and this problem is marked hard. This problem is marked hard. Let me draw a circle over here. This problem is marked hard. Shape outline, this will be red. Okay. So this problem is marked as hard. And now we will read the problem statement. You are given a m into n 2D integer array grid. Okay. So you are given a 2D integer array. So basically you are given a matrix of size m into n. There are m rows and n columns in the matrix. Okay. There are m rows and n columns in the matrix. Let me draw a matrix for your understanding. Let me draw a matrix for your understanding. This I copied here and now I will paste it there. Here I will paste it. Okay. So this is a matrix. Now here in the problem it is given that there is a m cross n matrix. So we have made a matrix of size m into n. M is the number of rows and n is the number of columns. And you are also given an integer k. An integer k is also given in the problem. You start at the top left cell. You start at the top left cell 0 0. Which is the top left cell? Let me change the color of the top left cell. The top left cell is this. Okay. So the cell uh, um, whose color I have changed to yellow, this is the top left cell. And your goal is to reach the bottom right cell. Okay, so basically the problem says that you are standing over here on the top right cell, and from this top left cell, and from this top left cell you have to reach to the bottom right cell. You have to reach to the bottom right cell. That means from the starting cell of the matrix you have to reach to the last cell of the matrix. Let me change the color of the last cell of the matrix as well, so that you could easily understand. Where is color table design settings? Let me change its color to uh, green. Okay, so cell with the yellow color is my starting cell of the matrix, and cell with the green color is the last cell of the matrix. And the problem says that you have to move from the starting cell to the last cell of the matrix. And they are also given two ways through which you can move inside the matrix. From one cell to another cell, you can move following two ways. First is normal move. You can move right or down from your current cell. Suppose if I am standing here on this cell, this yellow cell, if this is my current cell, then from this cell I can move to ij plus 1. Ij plus 1. Wait, uh, let me select a text box, and in this text box what I will do in this text box, uh, color will be yellow. Okay, so this is 0 0. This is what this is 0 0. So this is my uh, cell position of the starting cell 0 0. First row first column, first row first column. And from first row first column, if suppose I am standing here, then from first row first column I can move to ij plus 1. I can move to ij plus 1. I can move to ij plus 1. Ij plus 1, that means I can move here on this cell. Ij plus 1, that means I can move on the second column of the first row, and I can move to I plus 1 j. I plus 1 j, that means second row first column, second row first column, second row first column. That means here I can move. This is second row first column. So basically if I am standing here on the first cell of the matrix, then from the first cell of the matrix I have given two ways. Okay, and from those two ways I can select one way in which I have to go, I want to go. I can select that way. Like from every cell where we are standing, where we are present, from there we can move to our right cell. From there we can move to our right cell. Right cell is uh, this is my right cell. Suppose I am standing here, then from there I can move on to this cell. This is my right cell. Okay, this is my right cell. I can move here. let me increase the width. Okay, or I can move, or I can move, or I can move, I can move here on the bottom cell. I can move on the right cell, or I can move on the bottom cell. Okay, so I can choose any one. I can choose any one way of these two ways to move inside the matrix. If I am standing here, then from here I can move to my right cell, or I can move to my bottom cell. Now, um, the cost is the value of the destination cell. Suppose if I move from this cell, from my current cell to my right cell or to my bottom cell, then the cost that I will be charged, it is equal to the value of that cell, the value of that cell in which I want to go, the value of that cell in which I want to go. Okay, I am standing here. So if from this cell, if I want to go onto this cell, then I will have to pay 12 rupees because the value of this cell is 12. So to go onto this cell, I will have to pay 12 rupees. And if I want to go onto this cell, the bottom cell, then the value of the bottom cell is also 12. So I will have to pay 12 rupees. So if I have to move right or if I have to move bottom, in both these cases, here I will have to pay 12 rupees. Okay. So let me make one thing very clear. Let me make one thing very clear for you all that cost. Oh, let me make one thing very clear for you guys that cost of um, moving from one cell to another cell, cost of moving, that is equals to the value of the destination cell, value of the destination cell. Cost of moving is equal to the value of the destination cell. If I am currently on this cell, a starting cell, then if I move onto the right cell, then the value that I will be charged, it will be equal to 12 because the value inside the right cell is 12. So I will be charged 12 rupees to move on to the right cell. Or if I want to move to the bottom cell, then in that case also here I will be charged 12 rupees because the value in the bottom cell is 12. If suppose the value in the bottom cell is 10, so in that case, if I move to the right cell, then I will be charged 12 rupees, and if I move to my bottom cell, then I will be charged 10 rupees. Okay, so the cost of moving from one cell to another cell depends on the value that is given inside the cell where you want to go, where you want to move. Okay, and now the next thing in this problem is given teleportation means moving from one place to another in just seconds. That is the meaning of teleportation. Now in this problem, it is given that you can teleport from any cell ij. Suppose if I am standing here 0 0, then from 0 0 I can move onto any cell. I can move onto this cell, I can move onto this cell, this cell, this cell, any cell. I can move on to any cell XY. But there is a condition. And the condition is that you can only teleport from one cell to another cell if the value of that cell where you want to teleport, the value of that cell is less than or equal to the value of your current cell. Okay, the value of that cell is less than or equal to the value of your current cell. You can only teleport. You can only teleport. You can only teleport if the value of the cell on which you want to teleport, the cell on which you want to you want to teleport is less than or equal to the value of your current cell. Okay, you can only teleport from one cell to another cell if the value of the cell on which you want to teleport is less than or equal to the value of your current cell. Suppose um if I am on this cell, starting cell, so the value of the starting cell is what? The value of the starting cell is what? The value of the starting cell is, wait, uh, the value of the starting cell is what? The value of the starting cell is 14. Look at here. I am typing here. The value of the starting cell is 14. Okay. So if I want to teleport, to any other cell from this starting cell, then on how many cells I can teleport from here, from the starting cell? The value of the starting cell is 14, and the condition given is that you can only teleport if the value of the cell on which you want to teleport is less than equal to the value of your current cell. Okay. So the value of my current cell is 14. So from here I can only teleport to those cells the value of which is less than or equal to the value of my current cell. Okay. So from here, can I teleport to this cell? The second cell, the right cell. Yes, I can teleport to the right cell because the value of the right cell is 12, and 12 is less than equals to 14. This condition is true. 12 is less than equals to 14. This condition is true. So from this starting cell, I can teleport to this cell. Okay. Can I teleport to this cell? Third cell. The value of third cell is 9. So yeah, the value of third cell is 9. So I can teleport onto this cell because the value of this cell is less than equal to the value of my current cell. The value of my current cell is 14 and the value of this cell is 9, and it is less than equal to 14. So the condition is true. That means I can teleport from this cell to this cell directly. Okay. Can I teleport to this cell, the value of which is 10. Yes, yes, I can teleport onto this cell because the value of this cell is 10 and 10 is less than equal to 14. So the condition is true. That means I can teleport on this cell as well. Can I teleport onto this cell? The value of this cell is 8. Yeah, I can teleport on this cell because the value of this cell is less than equal to, the value of this cell is less than equal to the value of my current cell. 8 is less than equal to 14. So this condition is true. That means I can teleport on this cell. I can, in the similar way, I can also teleport on this cell because the value is 5 here. On this cell also I can teleport because the value here is 8. This cell I can also teleport because the value of this cell is 5. And I can also teleport onto this cell because the value of this cell is 0. Because the value of this cell is 0. Okay. Now, one more thing is given here, that the cost of this move is 0. That means if you teleport from any cell, if you teleport from any cell to any other cell, then that will charge you 0 rupees. That will charge you 0 rupees. That will charge you 0 rupees. 0 rupees will be charged. 0 rupees will be charged to move from, or I can write here teleport from. That will be better for your understanding. 0 rupees will be charged to teleport from um, any cell to any other cell. 0 rupees. That means no cost. No cost will be uh, taken from you to teleport from one cell to another cell. Teleportation is free. Teleportation is what? Teleportation is free. I will write it here. I will write it here. What I will write here? I will simply write here that hey, teleportation. This thing is very clear. Teleportation is free. Teleportation is what? Teleportation is free. I will place it here so that you can see it very clearly. Teleportation is free. No money will be charged. No money will be charged from you to teleport from one cell to another cell. To teleport from one cell to another cell, you will be charged no money. It is totally free, free of cost. And the last thing that is given in the problem statement, that we have to return the minimum total cost to reach cell m minus 1 n minus 1. That means the last cell. The last cell, the cell which is colored green, from 0 0. That means the cell which is colored yellow. So from the starting cell, if we have to reach to the last cell of the matrix, then we have to always keep one thing in our mind, that we have to find out the minimum possible cost to reach from the starting cell of the matrix to the last cell of the matrix, from the starting cell of the matrix to the last cell of the matrix. So now, in a very short manner, I will quickly tell you the whole description of the problem. Basically, the problem says that you are standing over here on the starting cell of the matrix, and you have to move, you have to reach to the last cell of the matrix, and you are also given an integer k, and this integer k tells you that how many maximum teleportations you can make in that particular problem. And you can move inside the matrix in two ways. First is normal move and second is teleportation. In normal move, from every cell on which you are standing, you can move either right or bottom, either right or bottom, either right or bottom. Suppose I am standing here on this cell, starting cell, so from here I can move onto the right cell whose value is 12, or I can move onto the bottom cell whose value is 10. In the same way, if I am standing here on this cell whose value is 12, so from here I can move on to this cell, right cell, whose value is 9, or I can move on to the bottom cell whose value is 8. Okay, so on every cell, on every current cell, I have two choices. I have two choices to select my move. Either I can move right or I can move bottom. And the cost is the value of the destination cell. So the cost that will be taken from you to move from any cell to its right or bottom cell, that will be equal to the value of the cell on which you want to move. Suppose I am standing here on the cell, on this cell, and from this cell, if I want to move onto the right cell, so I will be charged 9 rupees because the value of the right cell is 9. Or if I want to move onto the bottom cell from this cell, then I will be charged 8 rupees because the value of this bottom cell is 8. Okay, so the cost that will be taken from us to move onto any cell, that will be equal to the value of that cell. That will be equal to the value of that cell. And second thing in the is given teleportation. You can teleport from any cell ij to any cell xy. Okay, from any cell ij, I can teleport to any cell xy, but there is a condition that the value of the cell xy, it should be less than or equal to the value of the cell ij. Okay, that means the cell on which I want to teleport, the value of that cell should be always less than or equal to the value of my current cell. Okay, and the cost of this move is 0. That means teleportation is free. I have written over here that the teleportation is free. You will be charged no money for teleporting from one cell to another cell, and you can teleport at most k times, k number of times. Okay, and what you have to do, you have to return the minimum total cost to reach cell m minus 1 n minus 1. That means last cell of the matrix, from the starting cell of the matrix. You have to calculate the minimum cost. What is the minimum possible cost on which you can travel from the starting cell of the matrix to the last cell of the matrix? So I think that you have understood the problem statement, like what the problem wants to say. Now next I will see the constraint. Constraint here is mn. The value of mn is greater than equals to 2 and less than equals to 80. Then that means the maximum value of m and n can be 80. Okay, so the um, in the problem we can be given a matrix of 80 rows and 80 columns. Okay, and the value of and the value present inside every cell, that will be greater than equals to 0 and less than equals to 10 raised to the power 4, and k will be greater than equals to 0 and less than equals to 10. That means maximum teleportation that we can do, it cannot be greater than 10. It will always be greater than equal to 0 and less than equals to 10. So if we uh, on every cell we have three things we can do from every cell. From every cell we can do three things. What three things we can do from every cell? um, from every cell we can either move right. So from every cell we can either move right, or we can move bottom, or we can teleport. Okay, so from every cell what we can do from every cell, what we can do, we can either move right, or we can move bottom, or we can teleport. So three things we can do. Okay, so if I use the simple approach to solve this problem, then in that approach, suppose uh, worst time complexity will be, if suppose number of rows is 80, so into 80 into 80 80 rows and 80 columns. If suppose there is a matrix given to us which has 80 rows, and 80 columns, and 10 10 times we can teleport. In the problem it is given that we can teleport 10 times. Then the time complexity will be equal to 80 into 80 into 10. 80 into 80 into 10, that is what? That is 64 into 10 raised to the power 64 into 10 raised to the power 3. This can be our time complexity in case if we are given a matrix of 80 rows, 80 columns, and the value of k is 10. So uh, the time complexity can be 64 into 10 raised to the power 3, and this time complexity can cause TLE, that means time limit exceeded, and our problem will not get solved. So what we can do to solve this problem? To solve this problem, first thing that we can do is, first let's take this example. Through this example I will first let's copy this example here. On the next screen I will copy this example, and here I will try to understand you. Everything. There I will copy this. Sorry, my bad. Uh, I will copy this. Here I copied this, and I will put all these. I will arrange all these values in this matrix. So the value in the first cell of the matrix will be 1, as given in the example. I am arranging all the values as given in the example. So here 1, here 3, and here it is. Here it is also 3, 3, 3, 1, 3, 3, and then 2, 5, 4. 2, 5, and here 4. And then here it is given 4, 3, 4, 3, and 5. So this is what? This is our grid matrix. This is what? This is our grid matrix. Here I will write it for you. What I will write? This is what? This is grid matrix. This is what? This is grid matrix. This is grid matrix. And now to solve this problem, we will construct a matrix of the same size, m cross n. Okay, we will construct a matrix of the same size. This is our new matrix, and in this matrix what we will do, at a starting we will place max value. I write here max value in every cell of the matrix. I will place max value in the starting. Max. Here also max. Here also max. But here I will write 0 0. Why I will write here 0 0? Because uh, in the question I am said to reach to the last cell of the matrix, and if I am actually on the last cell of the matrix, then I will have to pay no money to reach here, because I am already standing here. If I am already standing here, then I will have to pay no cost. Okay, I am already on the last position of the matrix, so why will I pay any cost? I do not have to move. I am on the correct place. Okay, so that's why I have put 0. here in the last cell of the matrix. I think you have understood this thing that in all the cells we have put max value, and in the last cell I have put 0, because the question says that our goal is to reach to the last cell of the matrix, and if we are standing on the last cell of the matrix, then actually we will have to pay no cost. The cost will be 0 because we are already on the last cell of the matrix. Okay, so this is what this is cost matrix. This is what this is. Oh, sorry. This is what this is. This is cost matrix. This is what this is. Cost matrix. Here I will write cost. This matrix I have constructed only to compute the cost to reach the last position of the matrix from every cell. That's why I have constructed this matrix. Now what I will do? Um, now I will um, now I will from every cell. I have two choices. Either I can move in normal move. I have two choices. Either I can move right or I can move bottom. I can move on to the bottom cell. So what I will do here, I will write down a method to compute cost to reach the last position of the matrix from every cell. I will write down a method like and I will traverse in this matrix from the last position. From the last position of the matrix, I will traverse in this matrix. Like suppose I am on the last position of the matrix, then from here I cannot go to the right cell because right cell does not exist, and from here I can also not go to the bottom cell because bottom cell does not exist. So next what we will do, come here on the um, previous cell of the matrix. We are traversing from here, like firstly we are here on the last position of the matrix, then from here we traverse to this position. Okay, so we will put here one um, one condition we will put here. Let me write down that condition, then everything will be very clear to you. I will put here condition. What condition I will put? I will put here that suppose if I am standing here on this cell, then I will put key if from here I will first look to my right, look to my right side. Um, so here I will write if j plus 1. When I will look to my right side, then that means that I'm looking to my next column. I'm looking to my next column. Next column. So I will write here. I will put here a condition that j plus 1 is less than what? Less than n, the total number of columns. If it is less than n, then what I will do? Cost I cost ij is equals to math dot minimum of cost I comma j and um, cost of I j plus 1, cost of I j plus 1 plus cost of I j plus 1 plus grid of I j plus 1. This thing I will do here. I will do this thing here. Okay, I will do this thing here. uh, wait. Okay, if the next column exists, then what I will do, I will take the minimum the cost of my current column, and the cost which is present on the next column. The cost which is present on the next column, that is the minimum cost to reach to the last position of the matrix. And there I will also do a plus with grid I j plus 1, because suppose this contains the minimum cost to reach to the last position of the matrix. But to reach from this position to this position, from this cell to its next column, we will have to pay a cost, and that cost will be equal to the value given in the destination cell that we have already uh, we have already read. Okay, so that's why cost I j plus 1 plus grid I j plus 1. Okay, that thing we have already covered, that to move from any cell to its right cell or to its bottom cell, we will have to pay the cost, and that cost will be equal to the value of that cell. If you want to move to the right cell, if suppose this is cell 1, if I want to move to its right cell, then its value is 3. So to move here, I will have to pay a cost of 3 rupees, and if I want to move to its bottom cell, then here the value is 2. So I will have to pay 2 rupees to move on to this cell. Okay, and every cell contains a minimum cost to reach to the last position of the matrix. So that's why I have done a sum of cost ij plus 1 and grid ij plus 1 here. And in cost ij, I will always store the minimum of cost ij and cost ij plus 1 plus grid ij plus 1, because I have to compute the minimum cost, to reach to the last position of the matrix. I have to compute the minimum cost to reach to the last position of the matrix. One more thing I will do here. Just look, one more thing I will do here. One more function. And in this function I will write here that if I plus 1 is less than m is what? M is number of rows. If I plus 1 is less than number of rows, then cost of ij equals to math dot minimum of cost ij and cost I plus 1 j. j and grid I plus 1, sorry, grid I plus 1 and j. Okay, this is this first condition, j plus 1 less than n. This we are checking for our right cell, for our right cell, that do our right cell exists. If it exists, if our right cell exists, then we will compute, we will compute the minimum cost. We will compare the cost actually, that if we are here, suppose, understand, if we are here on this cell, then, and we have to compute the minimum cost. In every case we have to compute the minimum cost. So from here, which will be the best decision, to move to the right cell or to move to the bottom cell? So here the best decision from this cell will be to move to the bottom cell, because the bottom cell has a less value, it has a value of 2, and the right cell has a value of 3. So actually the minimum value that we are getting, it is from our bottom cell. So that logic I am putting here, and I think you have understood this logic, that what I am trying to do using these two conditions. And now next thing what I will do, next thing I will do, uh, if suppose here I will create a map, I will create a map, and in that map I will store uh, the minimum cost, minimum cost possible for a value. In that map I will store the minimum cost possible for a value. Suppose I created a map. Okay, I created a map. This question, there may be problem for you, there may be problem for you to understand this question, because there are many things to do in this question. That's why this question is marked as hard. Okay, so what I will do here, I will create a map, and in that map I will store for every value in the grid, I will store its minimum cost. Okay, so for every value in the grid I will compute its minimum cost, compute its minimum cost, compute its minimum cost. So here what I will do, here I will put a condition that uh, I have a hash map. Okay, actually I have a not hash map, I have a tree map, because I have to store all the key value pairs in ascending order according to the keys, ascending order according to the keys. So that's why I have created here a tree map. I will take here a tree map to store the key value pairs in ascending order. Okay, so here suppose 1, the value is 1. So for 1 what I will do, um, there will be a minimum value for 1, and similarly in similarly in that way what I will do, for 1 there will be a value in the map, for 2 there will be a value in the map, for 2 there will be a value in the map, and then for 3, 3 also, 3 is my key, and for 3 also there will be a value in the map, there will be a value in the map for 3, for 3, and then for 4, 4 there will be a value in the map, there will be a value in the map for 4, and then for 5, 5 we will store a value in the map, and the value which we will store here in the map, for every key the value that we will store here in the map, that will the minimum cost, that will the minimum cost. Suppose in this matrix, I will start from here. Suppose I am on the last position, so the value of the last position is 0. Okay, so from this last position, no right cell exists and no bottom cell exists. So we will move on to the next one, next one, next one. That means minus minus. Okay, previous column, previous column. We will move on to the previous column. Now in this previous column, what we will do? Max dot mean cost I here integer maximum value, and then cost ij plus 1. Cost ij plus 1. That means cost of its next column. Cost of its next column is what? Cost of its next column is what? Cost of its next column is 0 0. Here it is 0 0, and plus grid of ij plus 1. Grid of ij plus 1. So in the grid matrix, here it is, the value is 5. So 0 plus 5. 5 is because from here, if we want to move on to this next column, then we will have to pay a cost of 5 rupees. Then we will have to pay a cost of 5 rupees. Okay. And from this next column to reach to the last position, the cost, the minimum cost that it takes is 0 rupees. So 0 plus 5 is 5. So integer dot max and 5. The minimum value is 5. So here we will write 5. 5 is the minimum value, so here we will write 5. Now we will check that uh, do bottom cell exist, do bottom cell exist. So here we can see that the bottom cell does not exist. Here we can see that bottom cell does not exist. So here the value will be 5. Now we will next move to the previous column, move to the previous column. Now in the previous column, again we will compare with the right cell. In the right cell, cost, here cost is maximum, here actually cost is maximum, and in the right cell cost ij plus 1, cost ij plus 1 is 5. Okay, and plus grid ij plus 1, plus grid ij plus 1. From here moving on to the next cell, it will cost us 3 rupees. So 5 5, and its corresponding cell here in the grid matrix is 3. So 5 plus 3 is equal to 8. So here the minimum will be 8. Now we will check, does bottom cell exist, does bottom cell exist. Then here we will see that no bottom cell exists, no bottom cell exists. So what we will do, we will our this value will remain in this cell. Now we will move on to the next cell, means previous cell. So here we will move and here again we will compare the same thing actually, and also we will update our map. Okay, so when we were here on 5, so on 5 our minimum cost on 5 was what? On 5 our minimum cost was what? On 5 our minimum cost was 0. On 5 our minimum cost was 0, and when we were here on this cell, then for 3 the minimum cost comes out to be 5. So here we will write for 3 the minimum cost comes out to be 5. So for 3 key the value that we will map to that key, that will be 5. And when we come here on this one, so the value for 4, the minimum value that comes out to be, is 8. 8 is the minimum value for 4. And then now here we will do that. Does right cell exist? No, right cell does not exist. Does bottom cell exist? Yes, bottom cell exists. And bottom cell has a value 0, cost 0. And to move the bottom cell, it takes what? It takes 5 rupees. It takes 5 rupees. So 5 plus 0, 5. And 5 is less than max value. 5 is less than max value. So here what we will store? We will store here 5. Okay. And here in 4, 4, we will make an update. We will store the minimum value. Here in 4, we will store the minimum value. Now we will come here. See, does right cell exist? Then yeah, here right cell exists. Then what we will do? Um, the cost to reach to the last position from the right cell is 5, and from this current cell, the cost to move to the next cell is what? Is 4. So 5 plus 4 is 9. So 5 plus 4 is 9. 5 plus 4 is actually 9. So here we will store 9. And now we will check, does bottom cell exist? Then we will see that bottom cell exists, and from bottom cell the value to reach to the last position, the cost to reach to the last position is 5. And from this current cell, the cost to reach to the bottom cell is what? Is 3, because the value of the bottom cell is 3. So 5 plus 3, 8, and 8 is less than 9. So here again we will make an update. Here we will write 8, and we will move to the previous cell. In the previous cell, here it is maximum value. Okay, again we will compare, and here it was 5. So for 5, we will not make any update in the map, because 0 is less than 8. So we will not make any update here, and we will move to the previous cell, and here again we will compare it with the right cell. The cost present on the right cell is 8, and the cost to move from this cell to its right cell is 5. So 5 plus 8 is what? 5 plus 8 is 13. 5 plus 8 is 13. And from here, the cost of bottom cell is 8, and to move from here to the bottom cell is 4. So 8 4 is 12, and 12 is less than 13. So here we will write 12. Then again we will move to the previous cell. We will again move to the previous cell. Right cell does not exist. We will check its bottom cell. In bottom cell the cost is 5, and to move to the bottom cell it costs 4 rupees. To move to the bottom cell it costs 4 rupees. So 5 plus 4 is 9, which is less than the maximum value, 0, 9. Then we will come here, and here we will check the right cell. In the right cell, the cost is 9, and to move from here to the right cell is the cost that will be charged is 3 rupees. So 9 plus 3 is 12. And if we move to the bottom cell from here, then the cost is 8, and to move to the bottom cell, that is 5. So 13 is not less than 12. So here 12 will remain. Now the starting cell. On the starting cell, here to move to the right cell, the cost is 12, and the value here is 3. So 12 plus 3 is corresponding cell value. We will sum the corresponding cell value in both the matrices, grid matrix and cost matrix. So 12 plus 3 is 15. So here we will store what? 15. And to move to the bottom cell, the cost is 12. Bottom cell costs 12. And to move from this starting cell to the bottom cell, the cost is 2. So 12 plus 2 is 14, and 14 is less than 15. So here we will store 14. Okay. So now this is our matrix after one move, one normal move. After one normal move, this is our matrix. Okay. This is our matrix. And on 1 we will store what? 1 we will store 14. And on 2 what we will store? On 2 we will store 12. And this is our free map. Sorted map. This is our sorted map. Now this value we will check. This value is equal to this value. This value is equal to this value. 14 12 0 9 12 0 8 5 0 8 5 0. This is equal now. 14 12 0 9 12 0 8 0 5 and 0 8 0 5 0 0. Yeah, this is equal. So now what we will do? Now we will teleport. Okay, teleport. And how we can teleport? Like first we will for every value we will again create a hash map. This time we will again create a hash map. Okay. This problem is hard, and you will feel hard to understand this problem, but I am doing my best to make you understand this problem. Okay, a map, again a map. And what this map will do? This map will do what? This map will store. This map will actually be a map of this map will actually be a map of integer and list pair. In pair we will store the row and column of the row and column where that value exists. Okay. So in this map, what we will do? This is key. 1 is key. Okay, 1 is key, and the list will store all the positions where one exists. All the positions where 1 exists, it will store all those values. So 1 exists at 0 0. So 0 0, 1 exists at 0 0. Then 1 exists at 1 exists at uh, there is no other position in the matrix where 1 exists. So now next is 2. We will look for 2. Where does 2 exist in the matrix? So 2 exists at 1 0. You can see 2 exists at 1 0. So here we will write 1 0. Now 3. Now we will check for 3. In the matrix 3 exists at 3 positions. This is position number 0 1. Then again 3 exists at this position. This position is 0 2. Here it exists. And then last position is what? Last position is 0 1 2 2 1. 3 exists at 2 1. Okay. Then 4. 4 exists at 4 exists at 2 positions in the matrix. One is 1 2. One is 1 2. And the next position is what? Next position is 2 0. Next position was next is 2 0. And then 5. Where does 5 exist in the matrix? 5 also exists at 2 positions in the matrix. One position is 1 1, and the other position is what? Other position is 2 2. So 1 1 and 2 2. Here exists 5 in the matrix. So here in this hash map, we noted down all the positions where these values exist. Okay. So every time we do not need to traverse the whole matrix to find out the positions of every value. Okay. So that's why we have stored the positions of every value using a list inside a hash map. Now what next? Now what we will do? We will do teleportation. Okay. So in teleportation, what I will do? In teleportation, let me copy this on the next page. Okay. Let me copy this. These both actually. This thing I will copy on the next. This thing I copied. And this also I will copy. This also I will copy here. This also I will copy here. In the same way I will copy this one. I will copy what? I will copy this one. This one I will copy here. And then cost. Cost I will copy here. Okay. Now we have a map that stores the positions. Here I will write it. We have a map that stores positions, and what next? What we have? We have all the minimum values. Okay. We have all the minimum values. So now next thing that we will do is in teleportation. We all know that we can teleport from one cell to another cell if the value of the destination cell is less than equal to our current cell, then only we can teleport onto that cell. So what we will do, we will check for 1. There is no value in the matrix which is less than or equal to 1. So 1, if one wants to travel to the last position of the matrix at minimum cost, then it will have to pay a cost of 14. From 1, if you want to travel to the last position of the matrix, then we will have to pay a cost of 14. Okay, because there exists no cell in the matrix whose value is less than 1, so that we can compare the value of 1 with its value to store the minimum cost in 1. So now we will move on to 2. On 2, we will see that the value of 2 is 12. So we will compare this value 12 with 14. So actually the value at 12 is already less than 14. So we will not make any change on these cells inside the cost matrix where there is 2 in the grid matrix. Inside the cost matrix, there we will not make any change. Then we will move to 3. In the grid matrix, all the cells where there is 3 position. So what we will do on 3 position, we can see that the minimum cost is 5. Minimum cost comes out to be 5. So on every position inside the cost matrix where there is a 3 in the grid, on every corresponding position inside the cost matrix, there we will place 5, because we will place 5. Like here in the grid matrix, 3 is here. So here we will place what? We will place 5. Here it is also 3. So here also we will place what? Here we will place 5. And here also it is 3. So here also 5. So on all the 3 positions where there was 3 in the grid matrix, we placed 5, because teleportation costs no money. So if we teleport from this 3 to any cell which has a value of 3, so we will be charged no money to travel on that cell, and from that cell to travel to the last position of the matrix, the minimum cost is 5. That's why we have stored 5 in every cell of the matrix where there was 3 in the grid matrix. So in every corresponding cell inside the cost matrix, we have stored 5, because that is our minimum cost. Now after 3, so when we have 5. Okay, we have 5, the minimum cost, to place at every position of 3. So that's why I have taken here map of integer and list pair to store every position where 3 exists in the grid matrix. so that we do not have to travel through the complete matrix to find out all those positions where 3 exists inside the grid matrix. That's why I have already once traveled. I once already traversed through the whole matrix and stored the positions of every number. Position of 1, position of 2, position of 3, position of 4, and position of 5. Now next I will move to 4. The minimum cost at 4 is 5. So at every position in the matrix where there is 4, we will store 5. There we will store 5. Like here in grid matrix, there is a value of 4. So in the corresponding cell in the cost matrix, we will store a value of 5 because that is our minimum cost, 5. And here it is also 4. So here we will store 5, and then 5 for 5 the minimum cost is 0. So in the grid matrix where there is 5, so in the corresponding cell of the cost matrix, there we will store 0. There we will store 0 because the minimum cost to travel to the last position of the matrix is 0. Now this is what? This is our updated cost matrix after performing one teleportation. This is our updated cost matrix after performing one teleportation. And this is equal to this one. No, yes, this is equal to this one. 1405 05 12 00 05 05 00. Okay, 1405 05 12 00 05 05 05 and 00. Now again we will perform the normal move. Now again we will perform the normal move. We will stand here, see the right cell, see the bottom cell. Okay, then again we will stand here, see the right cell. Right cell, the value is 0, and here to move to the right cell, the value is 5 actually. So here here it will be 5. Now from here we will compare with the right cell. The cost to move to the last position of the cell from its right cell is 5, and the cost from this cell to move to its right cell is actually what? It is actually 3. Okay, so 5 plus 3 is 8. 5 plus 3 is 8, but already in a minimum cost of 5 we can move to the last position of the matrix. So why to put a value of 8 here? 8 is minimum, 8 is maximum, greater than 5, so we will not put it here because we have to compute minimum cost. Okay, now here it is 5. From here moving on to the next position, bottom matrix, bottom cell is 0, and from here if we move to the bottom one is then 5. So actually here it is 5, so no need to update value here. 0 is already minimum, no value in the matrix is greater than 0, so 0 is 0, we will also not update 0. Then here 12 is the value here. So from here if we move to the right, then it will cost us 0, and from here to move to the right it costs 5. Okay, so actually we can store here what? We can store here 5. Now from here moving to the bottom cell, it costs 4, and from bottom cell move to the last position, it costs 5. So 5 plus 4 9 is greater than 5. So here we will not make any update. Now here where it is 5. Okay, moving on to the next cell is 5, and grid in the next cell is 4. So 5 plus 4 is 9. Actually 5 is less than 9, so here also we will not make any update. And here also it is 5. Here also it is 5. Here also we will not make any update because the right cell has a cost of 5. Okay, and the bottom cell has a cost of 0, but to move from this cell to the bottom cell it costs 5 rupees. So 5 plus 0 is 5, and actually 5 is written here, so we have no value less than 5, so we will not make any update here. Now in the starting cell of the matrix, the value is 14. If we move to the right cell of the matrix, then there we get a value of 5. Okay, and from move from here to the right cell of the matrix, it costs 3 rupees. So 5 plus 3 is 8. So here we will update 8. Now we will compare this 8 with the bottom cell. The cost to reach to the last position of the matrix from the bottom cell is 5, and the cost to move from this current cell to the bottom cell is what? It is 2. So 5 plus 2 is 7, and 7 is less than what? 7 is less than 8. So we will update here 7. Now this is our cost matrix after again performing a normal move. Again, this is our matrix. And now what we will do, we actually have one teleportation left. Okay, in the question, in the example, it was written that here we can perform 2 teleportations. So one teleportation is left, so we can use that teleportation to reduce the minimum cost. Now here what I will do, this is 0 0, this is 5. So actually what I will do, again I will perform the same thing. Here it is 0. Okay, here it is on 1 it is 14. So 1 on 1 it is 14. On 2 actually we will do what? 2 on 2 actually we will update the value. Okay, this thing I just forgot. Here also we have to update inside the normal move. We have to check the right cell, bottom cell, and also we have to update the map. In the map we have to put the minimum value. So at position 2 the minimum value now is 5. At position 3 the minimum value now is what? It is also 5. And at position 4 it is also 5, and 5 is 0. And at position 1 the minimum value is 7. At position 1 the minimum value is 7. Now look. Now again when we see for 1 there is no value less than 1. So the value will here remain 7. No change. So for 2 the minimum cost is 5. Okay, so on every cell where 2 exists, where we will put a value of 5. So here exists 2, and here actually the value is 5. So no change. 3 5. So 3 on every cell where 3 exists, we have to put a value of 5. So here it is 3, and here it is 5. So no change. Here it is 3, the value is 5. No change. Here it is 3, the value is 5. No change. Then 4. For 4 the minimum cost is 5. So on every cell where 4 exists, we have to make the value 5. Make the value 5. So here it is 4 in the corresponding cell in the cost matrix. The value is 5. So no change. Here it is the value is 4. So the corresponding cell of the cost matrix the value is 5. So no change. And in 5 the minimum cost is 0. So here the corresponding cell of the matrix the value is 0, and here also the corresponding cell of the matrix the value is 0. So no change. If suppose we have more suppose in this question we have two teleportations. If suppose we had 5, 6, or even 10 teleportations, huh? And in suppose any teleportation, no updates were made, like no values were changed, no value actually changed. So what we will do, we will simply return the value that is present in the starting cell of the matrix, because this is the minimum cost that it will take to reach to the last position of the matrix. No changes we have to make, no changes we have to make. Simply we have to return this value of the starting cell. Simply we have to return the value of this starting cell. Okay. If in case if we did a teleportation and no values updated, if we did a teleportation and no values updated, that means we have got our answer. Now any number of teleportations we make, we are not going to get a cost minimum than this one, a cost less than this one, we are not going to get that cost. So this was the solution of this problem. This was the approach to solve this problem. I think that you would have understood the approach to solve this problem. Now we will directly move on to our code editor Leetcode, and there we will write down this code, and let's see if this code runs or not. Minimum cost. So here what I will do here I have actually um, here I have code already written. Um, yesterday night I had solved this question. Okay, so the code is already written, but for you guys I will again write the code. I will again write down the code. I will erase all this code and again write down the code from scratch. Okay, so this is given mean cost grid. Now in this grid, first I will do what? Number of columns. I will store grid dot length. Here it is my number of columns, and then grid zero dot length. This is my number of row. This is my number of rows, and this is my number of columns. Now what I will do here? Um, Here I will construct a matrix. Construct a cost matrix. Construct a cost matrix of size m into n. Of size m into n. I will construct a cost matrix, and in that matrix for I int I equals to 0, I less than m I plus plus. Um, in every array I will fill what? In every array I will fill a value equal to integer dot max value. Okay, integer dot max value I will fill in what? I will fill in every array. Every array I will fill integer dot max value. And lastly, what I will do? I know that on the last row and last column, the value is going to be 0, because it is our last position of the matrix. Now what I will do here? I will simply take here a private um, map. Map of what? Map of integer and list of pair. List of pair. And this will be my POS, position map. Okay. In this position map, what I will do? In this position map, uh, for int I equals to 0, I less than m I less sorry I plus plus, and for int j equals to 0 to j less than n and j plus plus, what I will do here? If if not, if not position dot contains key, if not position dot contains key, um, my grid of I j, if it does not contain grid of ij, then what I will do? I will put here in this map position dot put grid of I comma j, grid of I comma j, and new new array list. This is what I will do. And next thing that I will do is pos dot put. Put what? Put grid of I j. Sorry, put not. Here I will use get, because I have actually created the array list object. So position dot get grid ij dot add. Every time I will add what? Add a new pair. New pair of what? New pair of ij. New pair of what? New pair of ij. This thing I will do here. Okay, this thing I will do here. And I will um also here I will take a map. A map of what? Actually I will take here a map of um integer comma integer. Integer comma integer. I will take a map mp. And now what I will do here in this one, um now what I will do here, I will write down a method here. private void normal move. I will write down a method here, private void normal move, and in this method I will int grid and int cost. And the next thing that I will do here is grid cost, let's say m, and number of rows is n. Now what I will do here, for int I equals to m minus 1, I greater than equals to 0, and I minus minus, what I will do here, for int j equals to n, j greater than equals to 0, and j minus minus, what I will do here, um here in the normal move I will write down a function that if j plus 1, that means right one, if j plus 1 is less than n, then what I will do here, cost of I comma j is equals to math dot minimum of cost ij comma cost of I j plus 1 plus grid of I comma j plus 1. This thing I will do here. And then again, if I plus 1 is less than m, that means the bottom cell, then cost of I comma j equals to math dot minimum of cost I j and cost of I plus 1 j plus grid of I plus 1 and j. Okay. Now next thing what I will do, I will put here that if not if not if not map dot contains key what, grid of I comma j, then what I have to do, I have to put here map dot put what, put grid of I comma j, I have to put here. Okay, with integer dot max value actually. And what I will do here, map dot put um, grid of I comma j and math dot minimum of map dot get grid of I comma j, map dot get grid of I comma j and cost of I comma j, the minimum cost. Okay, this is the minimum cost that I will store here. Now what I will do, this is clear to you all guys. Now I will create here again a method. I will create here private void, not actually void, this method will be boolean actually, boolean teleport. This will be a method for teleportation. Okay, now in this method what I will do, teleport method int grid. Okay, int grid int cost. What I will do here, uh, for int I have stored all the key set where I have stored all the key set here. So actually for int value in map dot key set, what I will do here, for int map dot key set, what I will do here, I will actually take here two things. One is boolean, that is flag, and flag will be equal to what, flag will be equal to false. And one thing that I will take is int uh, minimum cost, that I will write down m cost. Okay, minimum cost, and this will be equal to integer dot max value. And now what I will write down here, I will write down here m cost equals to math dot minimum of m cost comma mp dot get value, and the minimum value will get stored in this variable m cost. And now what I will do, um, for pair p in position dot get value, for pair p in position dot get value, um, cost of p dot first and p dot second equals to m cost. Okay, and this will only happen if cost at p dot first and p dot second is not equals to m cost, then I have to do this thing, and flag equals to true. That means I have made at least one update inside the cost matrix through teleportation. Okay, this thing I have to do. And then what I will do here, I will simply return here flag. Okay, I will construct here This one is my position map. So this one is my position map. So here for position, I will construct a new hash map. Okay, and for MP also a new tree map. For MP a tree map because in MP I want sorted. I want a sorted map. Map should be sorted according to keys. Okay. Now next thing, MP equals to new tree map. Then the next thing that we will do is um, while actually um, k minus minus is not equals to 0 and teleport cost. Teleport what? Teleport cost. Actually, here's no need of this one. Only cost. Only cost is required here. Teleport cost. Teleport cost. What we will do for every teleport, we will do a normal move. For every teleport, what we will do? We will do a normal. What we will do? We will do a normal move. Normal move. Grid. After that, cost. After that, m and n. Okay, grid cost m and n. This thing I have to do. Here also I will do this thing once. Firstly, we will once move, normal move, grid, then cost, then m and then n. N actually. Okay. Now what I will do here, I will simply return here. Return what? Return cost of 0, 0. Okay. I will simply return what? I will return cost of 0, 0. And I will also write down here a class, pair class. Okay. I will write down here pair class. Pair class int first and second, two variables, and public pair int first and int second. This dot first equals to first, and this dot second equals to second. Okay, this thing we will do here. Okay, this thing we will do here. Okay, now I think that this whole method is ready. I think now it should work. It should work. We have not missed anything. We have write our code very clean, I guess. Now I should run it. Now I should do what? I should run it. Everything is very clean inside my code, and now I should run this code. If not pos dot contains grid ij, then yeah, put grid ij in url is. So now I think that this code is very clear. I think yeah, this code is very clear, and actually it's running. Okay, now I will submit this code and let's see if this code works or not. Okay, let's see if it works or not. This code, yeah, actually this code works. Look here, this code got accepted. So I have explained everything to you. Actually this problem was hard, but I tried my best to make you understand everything, every single approach that I did inside this code. Okay, so fine. Now we will meet in the next video. Till then, bye and take care.